Hey everyone, welcome to our next video. Let me go ahead and go to our notes. So our next section is 1.4. This is the trigonometric functions. Truthfully, I think 1.4 is probably one of the most important sections in all of trig. There's a lot of stuff in this section. It'll probably be a fairly longer video. There's really just a lot to cover in this one, and it really is just so important. There's some things we're going to learn in this section that if you can't really grasp these topics, it'll be very hard to grasp later topics and do other stuff down the line. So I have to say that this is probably one of the most important sections. So let's start off with this. Every angle drawn on the coordinate plane which is what we're usually drawing on, so the xy plane, can be drawn as a triangle. So what I mean by that is if I have the normal coordinate plane and I have an angle, there's a point that that angle is going to go through. We can call that point xy. And so if I draw it as a triangle, I have an x distance and I have a y distance. We will often call the hypotenuse the radius, and that's because if I drew a circle around this, that would be the radius of my circle. Now, if xy is any point other than the origin, on the terminal side of an angle, I'll just call it alpha, so we're saying alpha's here, in standard position. And this other stipulation has to be satisfied. That is that r is equal to the square root of x squared plus y squared. Then the following relationships are going to be true. Now, before I write the rest of it, I just want to mention this is Pythagorean theorem. This is x squared plus y squared equals r squared. To use Pythagorean theorem, like for that to hold, we have to be dealing with a right triangle. So if we are not dealing with a right triangle, then we are not able to use Pythagorean theorem, which means none of the other stuff I'm about to write would be true anymore. Also, I want to mention about this standard position. Standard position means the angle is touching the x-axis. So for instance, if I drew my angle over here, it needs to be touching the x-axis. If I drew it in quadrant 3, it needs to be touching the x-axis. If I drew it in quadrant 4, it needs to be touching the x-axis. So we will never be touching the y-axis. We're always basing our angle off of the x-axis. So that's what it means to be in standard position. So let me write the rest of this theorem. It says sine of alpha is equal to y over r. Cosine of alpha is equal to x over r. And tangent of alpha is equal to y over x. Now I'm going to put the names up here. Sine, this is cosine, this is tangent. Truthfully, there is a little bit of an expectation that you've already been slightly familiar with this, like at least sine, cosine, tangent, and Pythagorean theorem. Another way you might have talked about sine, cosine, and tangent is by saying like opposite, adjacent, and hypotenuse. So I'll bring that up at this point as well. So in a triangle, your x would be your adjacent side, meaning that it is touching the angle. Your y would be your opposite side because it's across from the angle. And then your radius is also called your hypotenuse. So I'll write those relationships as well. This would be opposite over hypotenuse. This would be adjacent over hypotenuse. And this would be opposite over adjacent. Now in 1.5, we'll actually talk about like the opposite, adjacent. We'll kind of use it that way a little bit more, but I'm really fine with you using it now at this point as well. I like to use it myself when I use sine, cosine, tangent. Cosecant is r over y. Secant of alpha is r over x. So if you notice, cosecant is just sine flipped. Secant is just cosine flipped. And then we also have cotangent, which is tangent flipped. I'll write those names here. So this is cosecant. This is secant. And this is cotangent. And we could write it this way as well. So some different things to think about while you're doing these. You can use the fact that it's x, y, r. You can use opposite, adjacent, hypotenuse, whatever you're comfortable with. But remember that these are defined as like ratios. So sine of an angle is this fraction. So there's going to be some times later where maybe I say something like sine of alpha is equal to 3 over 5. Sometimes I'll notice that people will, like in like an equation or something, they'll replace just the angle with 3 over 5, not the entire thing. Please be careful about that. Also, sometimes you'll see parentheses around these angles. That's really a notation thing. I like to do it, but sometimes I do forget. Also, we want to mention here that no denominators are 0. If we do get a denominator of 0, we're going to call that undefined. It is possible, so we'll talk about it. Also, I want to mention here that if you notice how cosecant is the opposite of sine, secant is the opposite of cosine, meaning like it's flipped, really what that is the reciprocal. So cosecant alpha is reciprocal of sine of alpha. Secant is the reciprocal of cosine, and then cotangent is the reciprocal of tangent. So we're going to see some other relationships form. So cosecant of alpha is also equal to 1 over sine of alpha. You could also write it as sine alpha is equal to 1 over cosecant alpha. Secant of alpha is equal to 1 over cosine of alpha, or we could write that as cosine of alpha equals 1 over secant alpha. Cotangent is equal to 1 over tangent alpha, and I could also write it the opposite way. So this is what it means to be the reciprocal. Sometimes we'll need to use these relationships that I just wrote. Sometimes we'll use these up here. It really just depends on what we're doing, what the problem is and stuff like that. I also want to mention something to you, that tangent of an angle, you may already know this relationship, but it's equal to sine of alpha over cosine of alpha. And the way we can show that this is true is because sine of alpha is equal to y over r, and then cosine is equal to x over r. If we simplify this, we get y over r times r over x. What I'm doing here is I'm multiplying by the reciprocal. So remember, when you divide, that's the same as multiplying by the reciprocal. These r's would cancel out, and I'd be left with y over x, which is indeed true. That's what we get for tangent. So sometimes we may want to use the fact that tangent is sine over cosine. Also, cotangent is cosine over sine. So I know this is a lot to remember if this is new for you, but these are things that we will be working with the entire quarter, all throughout this course. So it is good to try to start remembering these sooner rather than later. Let's go ahead and do an example of using some of these functions. So example 1, I'll say find the values of the 6 trig functions of the angle alpha in standard position whose terminal side passes through the point. Oh, it's not writing. Hold on. There we go. 2, -1. So we're looking for the values of all 6 trig functions. So we're going to have to find sine of alpha. We're going to need cosine of alpha, tangent, cosecant, secant, and also cotangent. So I'm going to have to find all of these. I'm just going to make myself a little table to write them in. That way it's nice and organized. And so it tells me that this angle alpha is in standard position. That means it touches the x-axis. And we also go through the point 2, -1. So 2, -1 is going to be in quadrant 4. So I'll go ahead and draw it here. Draw my angle. So please remember the fact that it's in standard position, that tells us that my angle is here, not here. So it always needs to touch the x-axis. And I'm also going to make this into a triangle. So my x distance was 2, and my y distance was 1, -1. Now for a lot of these, I'm going to need a little bit more than just the x distance and the y distance. I'm also going to need the hypotenuse, or you can call it r. So I'm going to go ahead and get that next. So I'm going to find r, because I know that this is x, I know that this is y. So r is equal to the square root of x squared plus y squared. That's just Pythagorean theorem. So I get square root 2 squared plus -1 squared. It's going to give me 4 plus 1. So I get square root of 5. Now I'm going to write all of my relationships in on this table over here. So sine is the y over the r. So I'll get -1 over square root 5. You can also think of it as opposite over hypotenuse, whichever one you prefer. On the test, I'm usually okay with you leaving your answers like not rationalized. However, on the homework, you will have to rationalize these. Rationalizing means to get the denominator out of to get the radical out of the denominator. So to do that, I would multiply by root 5 over root 5. So this would give me -√5 over 5. So this is the fully simplified answer, and that's what the homework is going to want from you. If you don't simplify on the test, I will not take off points, but it is something to consider. Cosine is our x over our r, so that's going to be 2 over root 5. Again, I don't want a radical in the denominator, so if I rationalize this, I'll get 2 root 5 over 5. Tangent is y over x, so that's going to be -1 over 2. Or you can think of it as opposite over adjacent. Cosecant is going to be the opposite of sine, so that's going to be -√5 over 1, which can simplify to just -√5. Secant is the opposite of cosine, or you can think of it as r over x, so that's going to be √5 over 2. And cotangent is the x over the r, or you can think of it as opposite of tangent, so that's going to be -2 over 1, so just -2. Now I do want to make a comment here that some of these are negative and some of these are positive. There's going to be a relationship that we will see, so let me write this out as which ones are positive or negative in each quadrant. That may be a question that you have. And so of course I'll show you how to figure this out. So it's really about remembering which ones have to do with the x value, which ones have to do with the y value, and then whether or not that x or that y is positive or negative in certain quadrants. So for instance, in quadrant 1, we have positive x's and positive y's. So all trig functions will be positive. R is always positive. Maybe I'll put that as a note here. R is always positive. In quadrant 2, we're going to have negative x's, but we're going to have positive y's. So we want to think which trig functions are going to deal with y and which ones are going to have to deal with x. So if we think about this, sine and cosecant are both going to deal with y over r. All the rest of the functions, so cosine, secant, tangent, and cotangent, are all going to have to use that negative x, so they're all going to become negative. So the only ones that are positive will be sine and cosecant will be positive. If we look at quadrant 3 has negative x's and negative y's. So we want to think about what sine, cosine, what everything is doing. So sine is going to be negative y over positive r. So that one's going to be negative. Cosine is going to be a negative x over a positive r. So that's also going to be negative. Now tangent is going to be a negative y over a negative x. So we're going to see those negatives cancel. So in quadrant 3, tangent and cotangent are going to be your only positive functions. And then lastly, for quadrant 4, we're going to have positive x's and negative y's. So that means that cosine and secant both are just positive x over positive r. So those are going to be positive. So cosine and secant will be positive. Sine, cosecant, tangent, and cotangent are all going to use that negative y. I hope that I've said all of that correctly. I hope I didn't mix up any of the x's and y's or anything as I was saying all that. If I did, I do apologize. Now there's also kind of a quicker way that I can teach you to remember this. I really do think it's important to know the why, and that's kind of what I've just explained. But another way you could remember this is there's an acronym. So it's A for all, S for students, T for take, C, the real saying is calculus, but I usually say courses. So all students take courses. I don't like to say all students take calculus because not all students take calculus, so I don't like to make that statement. Now, the way that this is used is this A means that all are going to be positive. This S means that sine and also its reciprocal will be positive. So T for tangent is positive, and then in quadrant 4, C for cosine, and then also its reciprocal would be positive. So that's how you know which ones are going to be positive or negative in which quadrants. Now I do want to talk about if we're at like the quadrantal angles, like how do we kind of figure those out? So let's see. So for example 2, I'll say evaluate the following trig functions. We'll just say that. So for part A, I want us to look at sine of 90 degrees. Part B, I want us to look at secant of pi. And then C, I want us to look at tangent pi over 2. So I put in 1 in degrees. I also did some in radians. So all of these angles, what's interesting about them is that they lie on the quadrant, like they are quadrantal angles, meaning that they lie like on the quadrant, like x or y axis. So if I look at part A, sine of 90 degrees. So what I'm looking at up here is I'm looking at 90 degrees, and I want to know what is sine if I look at that point. Now the interesting part of this is that we can really select any point on the positive axis to help us with this. In general, we're going to be working with the unit circle whenever we talk about these angles. So I'm just going to say that this is the point 0, 1. The reason I say 1 is because we're using the unit circle, so the radius is going to be 1, just as like a default. So if I think about this, so if I think about like what the radius would be, I just said that it's 1. So also my y distance is 1. So let me write this for us. I have x equals 0, right, because that's my x value. I have y equals 1. And then however far out I am from the center, that's my radius. So my radius is also going to be 1. Now we could go solve for it as well. You know, we could do 0 squared plus 1 squared square root. I still get 1. So either way you want to think about it. So what we'll see for this one, remember that sine is the y value over the r value. So I would get 1 over 1. So I get 1. So sine of 90 degrees is 1. Funny enough, it really wouldn't matter what radius we chose. Even if I made that point, 0, 2, I'd still get 1 because it'd be 2 over 2. If I did 30, I'd get 30 over 30. It would still equal 1 no matter what. Let's do the next one. So secant. So pi is going to be over here. So I'm looking at this angle here. I drew it over here because I want you to remember that it always comes from this side. So that's the entire angle. But that's where my angle is. And so these you're not really drawing as like a triangle as much, That's why I kind of wanted to go over them. So this is going to be the point -1, 0. And just as a reminder, I didn't have to pick 1. I could have picked -20 if I wanted to. So let's see, my x value here was -1, my y value is 0, my r, if I solve for it, I will get 1. So remember, secant is r over x, so this is going to be 1 over -1, so it equals -1. And then lastly, if I did tangent pi over 2, so pi over 2 is up here. It's the same location as 90 degrees. So same situation actually as part A. So my x value would be 0. My y value would be 1. My r would be 1. Now tangent is y over x. So what you'll notice here is that we get 1 over 0, which we would say is undefined. I'll also show you some other ways to do these as we go along, but this is just using like those relationships that we talked about earlier. The most common way that I like to talk about these is really just to use the unit circle. So something that we'll notice, remember this is 0, this is 90, this is 180, and down here is 270. In radians, this is 0, pi over 2, pi, 3 pi over 2, and then this would be 2 pi. In degrees, it would wrap around to 360 degrees. If we think about the unit circle, this is going to be the point 1 comma 0. This is going to be the point 0 comma 1. This is negative 1, 0. And this is 0, negative 1. This is if I think about a circle with a radius 1. What you'll notice about these is that every point on the unit circle is a cosine, comma, sine point. And the way that I get that is because remember that the radius equals 1 for the unit circle. So cosine of an angle would be x over r. So in this case, it'd be x over 1, so just x. Sine of an angle is y over r, so in this case it'd be y over 1, so just y. So instead of writing points as x comma y, I can also think of them as cosine comma sine. The reason I bring this up is because you'll want to get quick about recognizing these. So for instance, I want you to be able to quickly tell me the answer of any cosine, sine, tangent, anything at these angles. So for instance, if I ask you sine of 270 degrees, the way that I would get this is I would say, okay, the r doesn't really matter because it's 1. So great, we know that. I know that sine corresponds with the y value, so I would look at 270 degrees, the y value is negative 1, so sine is negative 1 at that location. Let's do another one for practice. Let's do cotangent at, I don't know, let's do pi. I'm just kind of making some up. So cotangent at pi, let's see. So cotangent is the x value over the y value. So in this case, negative 1 over 0, that's going to be undefined. So we want to be able to quickly get these. Let's look at another one. We'll do cosine of, let's do pi over 2. So pi over 2 is up here at the top. So I'm looking at this point for this one. So cosine corresponds with the x value. So here it would just be 0. So you want to be able to get pretty familiar with doing these and be able to do them quickly. That's why I kind of like to use this as opposed to going through. I'm trying not to erase that, but I was trying to erase the blue, but I'll just leave it. Also just realized I wasn't full screen this whole time. Sorry. So as we're going through these, like the way we did it necessarily in example 2 earlier, I feel like that's a little slow. We want to get a bit faster at that, and I think that seeing it this way might help that. Okay, let's go ahead and talk about some, not like, maybe I could say weirder angles. They're not necessarily weirder, but they're not on the quadrant. So we're going to look basically at these that are lying like inside the quadrants. So this is trig functions at 45 degrees. Remember that that's the same as pi over 4. It's just 45 degrees is the degree measure, and pi over 4 would be in radians. Now, of course, I do like to show where this kind of stuff comes from. So I'm going to show you where we get this 45-degree relationship. First, we start with a box. Let's say that I let every side of this box be 1. Now, if I split this in half down the main diagonal, I have a right angle there because it's a box. And so if this is a perfect square, and I know that because all the sides are the same, then if I split this angle over here in half, this would be 45 and this would be 45. And that's because they were originally 90 and we cut them in half. This shows me a triangle of 45, 45, 90. So I let my radius be 1. So let's go ahead and find out what my hypotenuse is. So my hypotenuse would be r equals x squared plus y squared, and then the square root. So I get square root 1 squared plus 1 squared. So I get square root of 2 out of this. So that means that this is going to be square root of 2. Now we can go get all of my relationships of sine, cosine, tangent, and all that. So sine of 45 degrees would be opposite over hypotenuse. And it doesn't really matter which one you look at. I'll look at this one since that one's in standard position, meaning it's touching the bottom, like the horizontal. So I would get 1 over root 2 for cosine of 45 degrees. I would get 1 over root 2. For tangent 45 degrees, I would get 1 over 1, so that's just 1. Now often you'll see these as rationalized versions, so root 2 over 2 will be your more common way of seeing sine of 45 and cosine of 45, but you could really see either. Cosecant of 45 would be root 2 over 1, so just root 2. Secant 45 would be root 2 as well. And then cotangent of 45 would also be 1. So the reason that we are looking at this is because what we're going to notice is that it does not matter how big the triangle is. If it has the angles 45, 45, and 90 inside, we're going to see all of these relationships of sine, cosine, tangent, and so on and so forth repeat themselves. So I want to make a point here, even if I had made the radius bigger, like if I hadn't used 1, let's say I had used, let's say I had used 3 for all of these instead, I still would have seen the same relationships happen. And I'll show you. Let's see, this would be 9 plus 9, so I'm going to get square root of 18. Square root of 18 actually can reduce into 3 root 2. And so we would have seen the same things happen, right? So this would have been 3 over 3 root 2. The 3's would have canceled. You're still left with 1 over root 2. And so on and so forth. So I won't harp on that too much. I just wanted to make the point that even if your triangle is bigger, you're still seeing the same relationships no matter what. So let's work with this. Let's do some examples. Oh, let me mention this as well. Remember that 45 degrees? I could replace all of those with pi over 4, and it would be the same thing. 45 degrees is just a degree measure, pi over 4 is the radians, so I can replace those depending on, what unit I want to work in. So let's go ahead and look at this real quick. I just want to show you. So on the coordinate plane, if I look at 45 degrees, that's right down the center. And so here's the triangle that I'm talking about for all of this. And I let myself have radius 1. Really because a unit circle, so usually we have radius 1. Well, I let my sides be 1. Maybe I didn't say that totally properly. I let my legs be 1. Okay, so let's look at, I don't know what example number this is in this section. I think we're on 3. We're on 3. So we're going to find the exact value of some angles. So we're going to say find the exact value of the following. And we'll do a few of these. So part A, I'm going to do sine of 135 degrees. Part B, I'm going to do cosine of 5 pi over 4. And I might make some more of these, but I don't want to crowd the space, so I'm going to start with this. So if we look at sine of 135 degrees, I'm going to go ahead and plot this first. So this is 180, this is 90, 0, 270. So 135 would be right in the middle of 90 and 180. So this is 135 degrees. Now, the point that I want to make to you is think about how big the angle is in the standard position. So really, here to here is 135 degrees. But what if I want to make it into a triangle? So what I want to ask you is how big, I didn't even have the eraser on, how big is this angle right here? How far is it from the nearest x-axis? And so I want you to pause and, of course, think about this. But from 135 to 180, I would do 180 minus 135. I'm going to get 45 degrees. So what this means is that I can write this as a triangle, and what I'm really looking at is a 45, 45, 90 triangle. Right, so it looked like 135 degrees, but that really just put us in a different quadrant. It didn't change the fact that my angle in standard position is really just 45. So what this tells us is that instead of thinking about 135, I can just think about sine of 45. So sine of 45 degrees is root 2 over 2. I'm getting that from up here because we found that earlier. So sine of 45 degrees is root 2 over 2. So sine of 135 will also be root 2 over 2. The only thing is I'm going to have to check the sign. So since I'm in quadrant 2, sign is positive there, and I can check that using all students take courses. So sign is positive in quadrant 2, so this is going to be positive. So that's my final answer. Let's do part B together. So I always like to draw them first. So 5 pi over 4, so I'm in radians. So this is 0. This would be pi. Since I have a denominator of 4, I want these to also have a denominator of 4. This becomes 2 pi. So if I multiply this by 4 over 4, I get 4 pi over 4. If I multiply this one by 4 over 4, I'm going to get 8 pi over 4, excuse me. So I talked about this with you in 1.2, I think, but like how to graph a radian angle. So 5 pi over 4 is going to be closer to 4 pi over 4. It's actually going to be right after it. So that's going to put it in quadrant 3. Now we want to ask, how far is it from the x-axis? Oh, I don't mean to have the eraser on. How far is it from the axis? So how big is this angle right here that I just drew? You know, what triangle are we really looking at? So from 4 pi over 4 to 5 pi over 4, that is pi over 4, which is 45 degrees. Remember that pi over 4 and 45 degrees are really the same thing, it's just they're in different units. So when I'm asking about cosine 5 pi over 4, it's really very similar to asking about cosine pi over 4. So since cosine of pi over 4, I'm going to look up here. So since that's root 2 over 2 as well, I know that this is going to be root 2 over 2. But I do have to check the signs. So since it's all students take courses, I'm in quadrant 3, so only tangent is going to be positive, tangent and its reciprocal. So cosine is going to be negative. I can also remember that the x values here are going to be negative, and since cosine relies on the x value, it's also going to have to be negative. Pause, take this in, go ahead and write me an email if you need to meet and talk about this further. But I am going to do one more. Let's do tangent of, let's do negative 9 pi over 4. This looks terrible. So a few ways to handle this. 1, you see how it says pi over 4? That means we're looking at a 45, 45, 90 triangle for this one. Another way that we can talk about this is often I'll call it the reference. So meaning like when I think about these up here, like this stuff, which one am I going to reference? And there's also a real definition for reference that we'll talk about in 1.6. But so if it says pi over 4 here, you can immediately know that you're dealing with a pi over 4 triangle, like you're looking at 45, 45, 90. But we still need to know where this is because we're going to need to know the quadrant so that we can know if it's positive or negative. So I don't like to deal with negative angles. So I want you to think for a second, what can we do with this so that it's not a negative angle anymore? And so the answer is coterminal. So if you add 2 pi, you can make angles not be negative anymore. So I'm going to go ahead and add 2 pi to this. Since I need the denominator of 4, I'm going to multiply by 4 over 4. So I'm really adding 8 pi over 4. Well, if I add this, I'm going to get negative pi over 4. That's still not ideal for me. I would really like a completely positive angle. So I'm just going to go ahead and do it again. So I'm going to add 8 pi over 4 again. And that's going to give me 7 pi over 4. So now I'm going to plot my angle. So I know that this is 0. I know that this is pi. I know this becomes 2 pi. So I can write this as 4 pi over 4. I can write this one as 8 pi over 4. 7 pi over 4 is going to be closer to 8 pi over 4. So that's going to make it in quadrant 4 because it's going to be right before it. Like 7 pi over 4 is right before 8 pi over 4. So here's where 7 pi over 4 is. But we want to think about how far is it from the x-axis. Like if we drew it as a triangle, so this would be pi over 4 here, because 7 pi over 4 to 8 pi over 4 is pi over 4 is the difference. So when I draw this as a triangle, I'm really just looking, at a 45, 45, 90 triangle. So what this tells me is when I think about tangent of negative 9 pi over 4, which is also the same as tangent of 7 pi over 4, it's going to have the same value as tangent of pi over 4. So that's when I'd come back up to these relationships and I'd say, okay, tangent of 45 degrees or tangent of pi over 4 is equal to 1. So I know that tangent of negative 9 pi over 4 is also equal to 1. However, I do need to check the sign. So all students take courses. So the C means that only cosine and its reciprocal are positive. So tangent is going to have to be negative. So if you are having trouble with any of these, please do let me know. We're going to look at some more. I know I told you this is a long video. If you need a break, take a break. The next type we're going to look at is, so this was 45 degrees. Next we're going to look at 30 and 60. So trig functions at 30 degrees, which is pi over 6, and 60 degrees, which is pi over 3. So we're going to look at both of these. Of course, I love to show y'all where stuff comes from. So this actually comes from an equilateral triangle. That means that all the sides are the same. Let's go ahead and make them all 1. If all the sides are the same, all triangles have to add up to 180, so all the angles would have to be the same. So this is going to have to be a 60, 60, 60 triangle. Sorry for accidentally writing 30 for a second. Then I split down the middle. So if I split down the middle, that's going to make this angle here 30 degrees. So now I'm looking at a 30, 60, 90 triangle. So the reason I wanted to split it is because I want the right angle. That way I can use Pythagorean theorem and all that stuff. So this side stays as 1. Since I split the bottom in half, this is now going to be a half. And now I got to go find the other side. So I know that r is equal to square root of x squared plus y squared. But I want to solve this for this side that's missing over here, so I need y. So I get r squared equal to x squared plus y squared. R squared minus x squared is equal to y squared. And now I'll plug everything in. So I get 1 squared minus a half squared equals y squared. 1 minus 1 over 4 equals y squared. 1 minus a fourth is 3/4. And then I need to take the square root. So I get square root of 3 over square root of 4, which is square root of 3 over 2. Sorry, I made y'all do some fractions there. So this is the relationship of a 30, 60, 90 triangle. So let's go ahead and write all of my trig functions. So first, let's look at the 30-degree mark. Now this one we have to be careful because I could just reorient the triangle, but I think we can get away with just using opposite, adjacent, and hypotenuse and all that stuff. We could reorient the triangle, but I'm not going to right at this moment. What I mean by that is if it bothers you to see the 30 up here, you could always redraw the triangle to have 30 here, 60 here, and then this would be root 3 over 2. This would be a half, and this would be 1. If you need to see it that way, then please, write that down, and you could do it that way. I'm just going to use the relationships of opposite and adjacent and stuff like that. Oh, sorry, I just hit my mic. So sine of 30 degrees, remember that sine is opposite over hypotenuse, so it'll be 1 over, oh, goodness, so it'll be 1 over 2 over 1. And that simplifies to just 1 over 2. Cosine of 30 degrees, cosine is adjacent over hypotenuse, so that's going to be root 3 over 2 over 1, so that's just root 3 over 2. Tangent of 30 degrees is opposite over adjacent, so that's 1 over 2 over root 3 over 2. If you simplify this, you'll get 1 over root 3. I can write all the other ones in here as well, or we can just know that if we run into, say, cosecant or secant or something like that, I can just flip sine, cosine, or tangent. So I'm actually not going to write all of them out. I do want you to remember that 30 degrees is the same thing as seeing pi over 6, though. And then let's go ahead and do the 60-degree one. So sine of 60 degrees is root 3 over 2 over 1. So that's just root 3 over 2. Cosine of 60 degrees would be 1 over 2 over 1. So that's 1 over 2. Tangent of 60 degrees would be root 3 over 2 over 1 over 2, which simplifies to just root 3. Also, I should probably say this here. You could also see this one as root 3 over 3. That's just the version that's been rationalized. I'm not really picky about rationalized or not rationalized, so whichever one you're comfortable with is fine with me. Now let's go ahead and try some problems out. I want you to know that as we're doing bigger angles, just like with the 45, it's always going to depend on how far are we from the x-axis. So for instance, if I say like 120 degrees, well, we're going to find out how far is that from the x-axis, and it's either going to be 30, 60, or 45, and that'll determine which one we want to look at. So I'm always just thinking about how far away am I from the x-axis. So let's do another example. I'm pretty sure this is number 4. And I'll say find the exact value of the following. So let's see, I'll make some up. Let's do cosine of 120. We'll do sine of negative 30. And I'll do some more, but I don't want to, run out of space or anything. So for cosine of 120, first I want to always plot it. So 180, this is 0. You'll notice I really only care about the x-axis, so a lot of times I won't even write the y-axis on there. I know 120 comes before 180, so it's roughly like here. So what we want to know is how far is it from the x-axis? So how big is this angle right here? So that's going to be 60 degrees. So that means that what I'm really looking at is the 30, 60, 90 triangle. So if I'm being asked about cosine of 120, I know that it has the same value as cosine of 60. So then I come up here and I say, okay, cosine of 60. So that's going to equal 1 over 2. So that means that cosine of 120 also equals 1 over 2. However, we do have to check because of the quadrant. So all students take courses. So S for sine is positive and it's reciprocal. So cosine is going to be negative. I can also just think that in quadrant 2, I have negative x values, so cosine is going to also be negative since it relies on the x. Part B, so negative 30. I don't like negative 30. I don't like negative angles. You can always add 360. So this is the same as saying sine of 330. If I add 360 to negative 30. So this is 180. This is 0, wrapping around to 360. So 330 is going to come right before 360. But I need to know how far is it from the x-axis. And in this case, it's 30. So again, I'm looking at a 30, 60, 90 triangle. So instead of thinking about sine of 330, I could just think about sine of 30. So if I look up here, sine of 30 equaled 1/2. So sine of negative 30 will also equal 1/2. But we got to check the quadrant. All students take courses, so it's going to be negative. Usually in a normal class period, I would, be asking, for questions and stuff like that. So if you are having any issues with this, please let me know. I don't want you to get too far into the course without knowing this, how to do this type of thing, because you're not going to be able to progress. This is really the most important section. You can't do anything else in the course without knowing this stuff. Let's do some with like radians, get some radians experience. So let's do sine of, trying to think of a good one. Let's do 5 pi, no, sorry, let's change my mind. 7 pi over 6, 7 pi over 6. And then part D, let's do secant of another radians one. I try to think about what quadrant and stuff I'm in. That way y'all can, get some more experience with different quadrants and stuff like that. Let's do, I'm so sorry, 2 pi over 3. 2 pi over 3. Let's do that. Sorry, I really shouldn't just pause that long, but I gotta make some up. Of course, sometimes I have some written, but then I decide to do different ones, so. All right, so 7 pi over 6. So I know this is 0, I know this is pi, this becomes 2 pi. If I want a denominator of 6, I'm going to write these with a denominator of 6. So if I multiply pi by 6 over 6, I get 6 pi over 6. I'll multiply 2 pi by 6 over 6, I'm going to get 12 pi over 6. Well, 7 pi over 6 is closer to 6 pi over 6. It's actually right after it. It's going to be roughly here. And if I think about how far away these are from each other, they have a difference of pi over 6. Remember that pi over 6 is the same as 30 degrees. So pi over 6 is the same as 30 degrees. So instead of thinking about 7 pi over 6, I want to think about what is sine of pi over 6, or sine of 30 degrees. Come up here. All right, it is 1 over 2. So that means that this is also going to be 1 over 2. But it's in quadrant 3, and sine is negative in quadrant 3. Let's do secant together. So 2 pi over 3, so this is 0, this is pi, this is 2 pi. And now I want a denominator of 3, so I'm going to have 3 pi over 3. If I multiply this by 3 over 3, this becomes 6 pi over 3. 2 pi over 3 is definitely closer to 3 pi over 3. It actually comes right before it. So that's going to put it in quadrant 2. The difference between these two is pi over 3. Remember that pi over 3 is the same as 60 degrees. Now this one's a little tricky because it's asking about secant. So we want to think, okay, I don't know secant by heart. So I do know that secant is just the opposite of cosine. So if I come up here and I think about what is cosine of pi over 3 or cosine of 60. So if I do that, I get 1 over 2. And then also cosine 2 pi over 3 would be 1 over 2 as well, but it's in quadrant 2, so it's going to be negative. And then secant is just the flip of cosine, so in this case it'd be negative 2 over 1, so just negative 2. Now be careful, if you ever get radicals in the denominator, you are going to have to rationalize those, at least for my math lab. Okay, so I mean, we can definitely do more of these. The thing is I can really exhaust the list. Like, we can do so many of these, it's crazy. Technically, there's 4, 5, 6, 7, 8, 9, 10. There's 12 in total angles that I can use, and I can do sine, cosine, tangent, cotangent, secant, whatever for each one of those. But if you're having any issues with these, please let me know. We're not really done with this because we will work with them a little. I mean, we'll work with them forever at this point. We'll see them again a little bit in 1.5 and then again in 1.6. So in 1.6, we do them a little bit more like thoroughly like this, almost again. But I really like the explanations in this section. I also wanted to mention that, see how this is pi over 6? That immediately means we can look at 30 degrees. See how this has a, oh, I hate that. See how this has pi over 3 in it? It means we can immediately look at 60 degrees. So that's actually the nice thing about radians. But sometimes students have a little trouble like graphing the radians, so I get that. Okay, so I do want to show you one more thing. I want to show you kind of an easier way than like remembering the triangles to remember like which ones are which. So this is a table. So this is remembering sine, cosine, so forth for all of these angles. So here's a little trick that can maybe help you. Sine, cosine, and then on this side I'm going to put my angles. So let's see. I'm going to do degrees, and I'm going to do radians in here. So in degrees, I'm going to do 0, 30, 45, 60, 90, basically just doing the whole first quadrant. In radians, this would be 0, pi over 6, pi over 4, pi over 3, pi over 2. And I'm going to show you a little trick. So for all of these, draw me a little line to separate it nicely. I want you to draw a square root, don't put anything in it, and then put it over 2. So for all of these, I'm going to do the same thing. I'm going to put an empty square root over 2. And so pause, make sure you've done that. I'm going to show you the next step now. For sine, we're going to count from 0 to 4 in our root. 0, 1, 2, 3, 4. And then it's just a matter of simplifying. So square root of 0 over anything would just be 0. Square root of 1 is 1, so over 2. This one doesn't reduce, it can just stay the same. This one doesn't reduce, it can stay the same. Root 4 would be 2 over 2, so this becomes 1. It's a little bit of a trick there to just count them down. Now for cosine, you start at 4 and you go up to 0. So this is 4, 3, 2, 1, 0. And again, you can reduce these. So hopefully this can kind of give you a nice way to remember these. I will reference back to this. A lot of times I just focus on this main part of the table. If you want to add tangent to this, you can as well. So if I wanted to maybe put, I mean, you could put any of them really, but I usually just focus on sine and cosine. But tangent is sine over cosine. So this would be 0 over 1, so just 0. This would be 1 over 2 over root 3 over 2. That's 1 over root 3. So I'm just taking sine over cosine. This would be 1. This would be square root of 3. And this one is undefined. So that's how I remember the 30, 45, 60. I think this is a nice way to help you remember that. But remember that if we have bigger angles, we're always just going to find out how far is it from the x-axis. And I'll tell you, it'll always be either 30, 45, or 60, at least for test 1. In test 2, we do talk about what if it's like not 30, 45, or 60, and we handle those a different way. Now, if I run into any like 0, 90, 180, and 270, if I run into any of these, I'll write it in radians as well. If I run into any of these, I remember the points. So this is 1, 0, this is 0, 1, this is negative 1, 0, and this is 0, negative 1. And remember, it's cosine of an angle, comma, sine of an angle. So if you're looking for cosine, you're going to look at the x value. If you're looking for sine, you're going to look for the y value. So these two things is what I'm going to reference like all the time throughout this course whenever we're dealing with kind of different angles and stuff like that. So that's it for this video. I know that was a bit long. I hope your attention made it, but if not, I hope you took some breaks if you needed them. If you are having any issues with this, I really can't stress it enough. Please reach out to me so I can help you. If we can't get through this, we can't get through the rest of the course. So it is so important to me that we get this down. So again, I hope you all have a wonderful day, and I will see you in the next video. Bye-bye.